Chances are you've used this operating system without ever even knowing it. It's a quiet workhorse in the tech world, and it's built on one of the most audacious goals in all of software, to run on absolutely everything. That right there, that's the official motto of the NetBSD project. Notice it's not a question, it's a statement of fact. It's a promise that this operating system can, and probably will, run on just about any piece of hardware you can possibly imagine. But how far can you really take that idea?
Yep, a toaster. I know this wasn't just some gimmick. It was a powerful and kinda hilarious demonstration of the project's core mission of extreme portability. So how in the world did they build an operating system so versatile it can run on everything from massive supercomputers to kitchen appliances? Well, the answer starts where so many great projects do, with a little bit of frustration.
To really get a handle on NetBSD's obsession with portability, we have to go back in time, back to the chaotic, Wild West days of early open source development.
So picture this. It's the early 90s. A group of developers are working on an early open source BSD variant called 386 BSD, and they are just fed up. They felt like the project was aimless, that it lacked a clear, open way for people to contribute. So they did what any self-respecting developer does. They decided to fork it and start their own project, built on a very specific set of ideals. Now, this was about more than just building yet another operating system. It was a direct reaction against the chaos they just experienced. Their new philosophy was simple but incredibly powerful. Focus on writing code that was clean, correct, and, this is the big one, portable. This disciplined approach would end up defining the project for decades to come. And man, they moved fast. The code repository goes up in 1993, and just over a year later, boom, their first multi-platform release is already out. But the early drama wasn't quite over. In 1995, one of the co-founders, Theo de Rat, was removed from the project. He then forked the code to create OpenBSD, which, as you might know, would become legendary in its own right for its intense, hardcore focus on security. And you know, that spirit of determined collaborative effort was even baked into the project's early logo. It was inspired by that famous Iwo Jima photograph, but here it symbolizes a small group of developers banding together to raise a flag over a mountain of discarded, random hardware, building something lasting and principled out of it. So how does that philosophy of clean, portable code actually translate into running on a toaster? Okay, let's pop the hood and look at the technical playbook that makes it all happen. The secret sauce, the magic ingredient that makes this all possible, is something called a hardware abstraction layer, or HAL. The easiest way to think about it is like a universal translator for hardware. It splits every device driver into two main parts, a big generic piece with all the core logic, and then a tiny little piece that talks directly to one specific bit of hardware. This means the vast majority of the driver code can be reused absolutely everywhere. And the result of this super clever design? It's staggering. NetBSD officially supports nearly 60 different hardware platforms, and that number represents an incredible journey through the history of computing, from the totally obscure to the mainstream. And, I mean, the diversity here is just wild. We're talking about everything from vintage servers and old desktops, to video game consoles like the Dreamcast and the Wii, all the way to early PDAs. The HAL is what lets that same core operating system feel right at home on every single one of them. But you know what? This obsession with portability didn't just stop at the kernel, at the very core of the OS. The NetBSD project took that exact same philosophy and applied it to the thousands of applications that run on top of it. And that brings us to pkgsrc, or package source. It's NetBSD's system for managing over 29,000 different third-party software packages. Because it was built from the ground up to be portable, it works so well that it's been adopted by tons of other systems. I mean, look at this. A huge chunk of its users are actually running it on macOS, Linux, and other BSDs to manage their software. How cool is that? But NetBSD's innovation didn't stop there. Not by a long shot. They kept pushing the boundaries of traditional OS design, rethinking not just what an OS runs on, but how it's actually put together. Okay, get ready for a bit of a mind bender here. What if a kernel driver could run just like a normal app? Now that sounds weird, right? Drivers are supposed to be buried deep inside the kernel, the most privileged part of the OS. But NetBSD's developers came up with a completely radical idea to make them portable in a whole new way. This radical idea is called the any-kernel concept, and it allows them to create these things called rump kernels.
The process is just fascinating. First, you isolate a kernel component, like a network driver. Then you run it in a safe, sandboxed area outside the main kernel, emulating all the connections it needs to think it's still inside. And just like that, the driver executes like a tiny, self-contained application completely portable to other systems.
The practical benefit here is just amazing. It means other, more experimental operating systems, like GNU Hurd, don't have to reinvent the wheel and write their own complex device drivers from scratch. They can just borrow NetBSD's proven, stable drivers and run them as simple applications. It's a testament to NetBSD's commitment to the entire open-source ecosystem, not just its own project.
So while you might not be running NetBSD on your desktop, its influence is hiding in plain sight, all thanks to that core philosophy of clean, correct, and reusable code.
You can see just how far its code has traveled right here. Its DNA is everywhere. It was in Apple's networking hardware, it was the OS on the T-Mobile Sidekick, and it's even in the networking stack of QNX, which is used in countless cars and industrial systems. NASA used it on the International Space Station, and you can still find bits and pieces of its code inside Android today. And of course, this incredible commitment to portability has another really wonderful side effect. For the whole retro computing community, NetBSD is like a magic toolbox. It breathes new life into all these beloved old machines from the 80s and 90s, keeping them humming along in the modern era.
So what's the big takeaway from all this? NetBSD might not be the most famous operating system out there, but its story offers a really powerful lesson about the value of thoughtful, principled engineering.
What NetBSD proves is that when you focus on the fundamental principles, clean design, careful implementation, and extreme portability, you create a legacy that outlasts all the fleeting trends. Its code has become part of the digital infrastructure we all rely on, running silently in the background of our lives. It's a powerful reminder that sometimes the most influential projects aren't the loudest, they're the ones built to last. Thanks for joining this explainer.